Hi, I'm Gabriele Berton, a PhD student from Politecnico di Torino, and I will present my research on visual geolocation for infrastructure and industrialization. The ninth UN Sustainable Development Goal aims at improving infrastructure and industrialization worldwide. This requires automation to achieve faster and more accurate decision making. Automation can lead to cheap, reliable, and sustainable transportation. Just to give an example on how automation and sustainability go hand in hand, we can look at the situation in Tallinn, the capital of Estonia. Tallinn is the biggest city on earth with free transportation, and it is also one of the first to test autonomous public buses. Autonomous vehicles and robots need to know their position in the world to be able to reliably reach their destination. Vehicle localization can be achieved in many ways. One example is GPS, although this is inaccurate and unreliable, and it doesn't work in underground scenarios. Another option is through LiDAR, although its high costs make it an unsuitable choice for most scenarios. Finally, the choice of using cameras and software is becoming the standard for a large number of applications. Cameras are cheap and reliable. This is where geolocation algorithms are needed, because camera stream needs to be processed by a geolocation method to obtain its position in the world. Visual geolocation is the task of quickly and reliably understanding the position of a video or a photo, making it a crucial task for automation. It is usually approached through image retrieval, where we have a large database of images of which we know the GPS coordinates, and when we obtain a new image, called query, we need to find the most similar image in the database. In this way, we can obtain a coarse estimate of the position, which can then be refined to obtain a precise position. To perform image retrieval, all the images are passed through a neural network, which is trained to recognize places and produces some sort of feature descriptors. The descriptors are then compared through a similarity search to obtain the final prediction. This is the focus of my research, for which I published multiple articles at the world's top conferences and journals on computer vision. I presented my first top conference article at the International Conference of Computer Vision, and the idea was to work pairs of images to simplify the task of finding correct positives for a given query, which achieved new state-of-the-art results. Last year, I led a joint collaboration with researchers from 3 European universities, which led to a publication to CVPR, the world's top conference in computer vision. The paper was a thorough benchmark with the goal of better understanding how to improve each component of a geolocation pipeline. In the same year, I also published a state-of-the-art method, which improved over previous works while speeding up computation by an order of magnitude, making embedded geolocation method finally applicable in real-world scenarios, without the need to rely on an external server. The method, called CostPlace, is also much cheaper than previous works both at training and test time, requiring only a single GPU for training. I'm proud to say that I've open sourced the code for all my projects, which have led to further research and got me connected to researchers all over the world. Due to my numerous publications and dedication to open source projects, I have been invited to give a 30-minute tutorial on geolocation at this year's CVPR, which will be held in Vancouver. The tutorial will also have 4 invited speakers from universities throughout the world and has been organized by researchers from the Stanford Research Institute and the University of Central Florida. And here is finally a demo built from the CostPlace method, which I've released last year, created from Lorenz Junglas from the Karlsruhe Institute of Technology. On the bottom right, you can see a query image from San Francisco, which is the image for which we need to find the position. We use as database millions of images from a San Francisco dataset. You can see here that the correct position is correctly found for the given query.